Okay. So determine the moment of inertia about the base of uh, a new section shown in the figure. Okay. So here they have asked only to find out the moment of inertia of the U section, right? About the base, not about the central axis. So now, which is the base here? Base is this one. Okay. This is the base, right? Okay, so this is the base, and that is actually x-axis, right? They have given it's a x-axis itself. So if you want, you can rename because if you may get confused otherwise. So we'll call this as AB. Okay, this line as AB, and then we need to find out the moment of inertia of this. Now, okay, so as I told you, step one is finding the centroid, right? So step one is determination of centroid. Okay, step one is centroid. Now, since they have asked only the moment of inertia about the base, is this step is necessary or not? Can anybody tell me? Is it required? Hello, unmute yourself and answer.
No, sir.
Uh,
Yes, sir. Yes, sir. Yes.
what? Yes or no? What do you mean by yes or what do you mean
Yes.
by no?
Yes, sir.
Yes means what?
We need to find the centroid.
We need to find out the centroid. Is it so?
So then we will find the centroidal axis, then use parallel axis theorem and find the moment of inertia about AB.
Actually, you can directly find out the moment of inertias of all these areas about the base itself, right? So if you add them up all together, that gives you the directly the moment of inertia of this entire section about the base. Actually speaking, that calculation you can do two ways. One is first you calculate IXX by finding the centroid, okay, and then apply parallel axis theorem to calculate moment of inertia about the base, okay, right? But if moment of inertia about x-axis is not being asked, you can directly find out the moment of inertia of all these areas about the base directly, and for which you don't need to calculate or you don't need to locate the centroid, isn't it? See, now I'll show you how it will be. So IAB is nothing but what? So moment of inertia, actually speaking. So now, in order to find out the moment of inertia, so how many how do you split this given area into? How many elemental areas will be?
Three.
Three. Anybody else?
So three, but two can be
Three.
considered as one.
No, say it can be considered as one, but it is no point in discussing about considering it as one because it will not give you any you don't have any formula to consider this as a one single u, right? But it has to be split into a number of areas. But how
Sir,
many?
can we like, divide it into two areas? One L and the other L is just symmetric. So will that help?
No, L section is again a complex area, right? You cannot find, you don't have a direct formula for L section as well, isn't it?
No, sir. Single L will give us two areas.
Huh?
Single L will give us two areas, no, sir. So
Yeah, two areas. Again, you need to consider that, right? That has to be divided into again that you see, as you said, you may be taking it as one L section this side and one L section the other side. Okay, but again that will be a complex area for which you don't know what exactly the centroid of that it will be. So you have to split such a way that you will be having the formula. So one way, let me explain. So one way is you divide the given area into three rectangles, isn't it? So this is area number 1, 2, 3. Now each one will have a direct formula. Yes or no? Yes or no?
Yes, sir.
Yes, isn't it? So each one will have direct area. I mean, direct formula for moment of inertia are centered. But if you consider as one any two L sections, so we don't have any formula for the centroid or moment of inertia. That's the reason why we need to split the areas into number of areas which are very elemental. They should be very basic areas, right? It may be rectangle, triangle, circle, semicircle, etc., etc. Okay, this is how you can divide. But is there any other way where to divide it such a way that the number of areas will get reduced to less? Definitely, it cannot be one. Okay, can anybody tell me how we need to split into two areas? There should be only two areas. Say
So the big triangle minus the missing part.
big rectangle. Isn't it? You are right, 100% correct.
X
Good.
cross I.
Yeah. So you consider this as a big rectangle, one big rectangle, minus of the other smaller rectangle. Okay. So that way you can consider only two areas to solve the problem, right? So when you in the beginning of the problem, you should be you think twice, thrice, such a way that the number of areas will get reduced, so that the problem can be solved in a easier manner. So we will be dividing this into two areas: one positive rectangle A1, and other one is a negative one. Okay, so negative one, I'll hatch it, I mean, using some yellow color. So this is the negative area which has to be subtracted from the given area. Okay, so and therefore you can find out the moment of inertia of this rectangle, and minus moment of inertia of this rectangle will give you actual moment of inertia about the base. Okay, therefore I can consider IAB is equal to IAB 1 minus IAB of second area. Okay, that's all you need to do it. Actually speaking, so in the previous problems, all the areas were positive areas. If you have a negative area, it's very simple. You just consider minus. Okay, formula remains same, everything will remain same. Only you need to consider negative sign. That's all. Okay, that's all will be the difference. So now, what is IAB1? What is moment of inertia of area A1? Okay, about the base. Actually, this is area. Okay, one second. So this is A2. This is area A2, and this positive area A1. Okay, can anybody tell me what is the formula for IAB1?
BD cube by 12.
BD cube by 12. That's it. See, we are not calculating the moment of inertia about its centroidal axis, isn't it? We are finding the moment of inertia about its base. Okay, moment
BD
of
cube by 3.
BD cube by 3. Correct, isn't it? See, this is the rectangle. Okay, so we have a rectangle, right? And that we are supposed to calculate. We are supposed to calculate the moment of inertia of this rectangle about the base. So which is AB. So we have directly the formula which is given by B1 D1 cube divided by 3. BD cube by 3 is the formula of moment of inertia of a rectangle. Next, what is moment of inertia of second area A2? Moment of inertia of this A2 about AB. Yes, unmute yourself. Answer to me. Hello.
So the moment of inertia about the centroidal axis plus the distance.
That is what we are. Okay, yeah, correct. Yes. So what? So parallax theorem you need to apply. In this case, so this is area A1. Area A1. In the second area, for the second area, so the area is located at some distance. Okay, from the axis. Okay, this is reference axis AB. So the moment of inertia of this A2 about this will be moment of inertia about its own central axis plus the square of the distance, product of area and square of the distance between two parallel axes. So therefore, here the moment of inertia will be equal to moment of inertia of the negative area, which is equal to, so let's say this is B2 and this depth is equal to D2. Okay, if that depth is equal to D2, any
2 cube
doubt?
by 12.
Yeah. So
Sir,
B2 dq by 12.
Ma-
Somebody having doubt?
sir,
Ah.
why can't we do it like this, sir? Just
Yeah.
consider single L. So in one single L, we'll get two areas. Sir.
Okay.
So if we find that moment of inertia considering only two areas, then double it can't be get, because the right side is also symmetrical also
Yeah.
to the left side. If we double the
Marvelous. Yes, that can also be done. Okay, you can do it. Thing is, if it is about the base, it can be done. About the central axis also, it can be doubled. You can do it. So there is no doubt about it. 100% correct. Good. Who is this?
Anant R.
Yeah, you can do it. Definitely, you can do it. Double that. So because of the symmetry, also that way also you can do. And this is the other way which you can do it. Okay. So yeah. So next A2 moment of inertia of the other negative area will be V2 D2 cube divided by 12 plus area A2 into
into 1.
the distance between two parallel axes. So which is equal to how much?
5.
So G2 will be somewhere here. Let us say G2 will be somewhere here. So this total distance, which will be equal to
0.5.
1
Yes,
plus 1 plus
3.5 total.
yes 3.1. Yeah, correct. So this will be 2.5 because 5 divided by 2 2.5 plus this one. Okay, this one. So it will be equal to 3.1 plus 2.5. You can write directly. Yeah. So 1 plus into, let's say I'll take it as yc square, okay? Yc2 the square, this is the formula. And let us then substitute the values, okay? B1 is, what is B1? 5 centimeter, 5 into D is 5 plus 1, 6. 6 is cube divided by 3 minus B2 is, B2 is, how much it will be? How much B2?
3.
3. 5 minus 2, it will be 3. Okay. So 3 into depth is, it will be, how much is the depth? 5, right? So 3 into 5 cube divided by 12 plus A2. A2 total is, that's what, same thing. 3 into 5. 3 into 5 is A2 into YC, which is equal to distance between two central axes, which is equal to 1 plus 2.5 this square, 1 plus 2.5 the square, okay, and that will give you moment of inertia about the base. Okay, so somebody just calculate the answer and let me know. That's equal to IAB. So 5, you can just calculate and give the answer. You understood, right? Any doubt? Anybody?
Yes, sir.
So actually, this is a very simple problem, but you can make it, if you want, complex, very complex, by taking 3 areas and all. Okay, or that's one thing. The other way you can make it complex is you will first find out moment of inertia of central axis and then try to find out about the base. That will also be complex. Okay. But if they are asked to find the moment of inertia about its central axis, you can do that. Okay. Now Okay. Somebody, have you got the answer?
145.
145. That's all. 145 centimeter to the power 4. Sorry. Anybody else? What are you doing, all of you? Try to calculate the answer and let me know whether this is right or wrong. So 5 into 6 cube by 3 plus minus this whole thing. Kannada calculator ilva? Aniruddha, Chandranshu, Chandan, Nyararu. So what are you, all of you doing? Okay, you just calculate that. Hello, be active. Hello, everyone.
Calculating.
5 into 6 cube by 3 minus 3 into 5 cube by 12 plus 3 into 5 into 1 plus 2.5 the whole square. So now let me add on to this problem again. So also find moment of inertia about. Also find moment of inertia about.
Correct, sir. 145, correct, sir.
Okay, then it's okay. We'll move on. About centroidal axis. Okay, that's nothing but okay. Let's say I-axis only. We'll just capture I-axis. I-Y-Y will be very symmetrical, so you can do it. Okay. Find I-axis, only I-axis. So similarly, you can find I-Y-Y, no problem. So now we are supposed to find out I-X-X, moment of inertia about X-axis. Okay, but we don't have X-axis. Do you have X-axis? So see, you may be confused if it is directly given as I-X-X because section, I mean, they have given X-axis as this. You may be thinking that you need to find out moment of inertia about this, and you will stop there only. But they have asked about centroidal axis. What do you mean by centroidal axis, and where exactly it will be there? Anybody? So centroid will be here, right? So let G be the centroid, and you need to find out the location of that. Okay.
The centroid will be below, sir.
Will it be? Yeah, actually, it's not exactly here. Okay. So approximately, as you said, it will come somewhere here, not come completely here. Somewhere it will come here, but according to my figure, it's looking like that. It looks like at the center. Okay. Okay, I'll correct myself. It's not actually for the scale. Okay. Now let me just correct myself. So you can draw it a little below. Okay. Maybe somewhere here. So centroid will come somewhere here. Okay, is it okay now?
Yes, sir.
Yeah. So somewhere here you will get it. So let that be x-axis. Okay. Let that be x-axis, and we need to find moment of inertia of about this axis, and also for which you need this y bar. Okay, y bar has to be found. And so we'll first find out the y bar and then think about finding moment of inertia about the centroidal axis. Okay, right. Next is moment of inertia about centroidal axis. Moment of inertia about centroidal axis. Centroidal axis. XX axis, XX axis. Okay, so we need to find out moment of inertia about XX axis. Now, for which so all of us know that we need to find out y bar. So y bar is equal to, very quickly, a1 y1 plus a2 y2 plus you can do it like that, but what we have considered here is we have considered this into only two areas, right? So only two areas, so that way only we can consider, and we can calculate the y bar. So a1 y1 a2 y2 divided by capital A minus a2. So a1 is equal to, here we'll keep calculating the values. A1 is equal to 5 into 6, okay? Capital A is equal to 5 into 6, right? And A2 is equal to, that's nothing but 30 centimeter square. A2 is equal to 5 into 3, or 3 into 5, okay? 3 into 5, which is equal to 15 centimeter square, right? Next, y1 and y2 values. So y1 will lie here. So let this be, sorry, will it be like here? Am I correct? It's not, right? So actually speaking, the y1 is nothing but distance of area A1, which will be there at the center. Okay, what is y1? Anybody tell me?
3.
So this is g1. So this distance from here to here is y1. So y1 is equal to
3.
6 by 2, isn't it? 6 by 2 and 3 centimeters. Okay. Therefore, so y2 is nothing but distance of g2 from x-axis, which is nothing but y2, and that value will be equal to, as we have already calculated, 1 plus 2.5. Okay, 1 plus 2.5, which is equal to 3.5. 1 plus 2.5, which is equal to 3.5, and we'll just substitute the values and we'll calculate. Okay, so maybe I don't know whether I'm doing right or wrong. Let me see how many of you will correct me.
So 2.5.
Huh?
2.5.
1 plus 2.5, it is 3.5, no?
No, sir, y bar.
Y bar value. Okay. So what is A1? What is
Sir,
A1?
should we do A1 minus, sir, A1 y1 minus A2 y2, no sir, numerator?
Yeah. That is okay. That is A1 minus A2. But here the value of A2 should be considered negative. Okay, that's all the difference. So A1 is value we have 30 into y1. Y1 is nothing but what is the value of y1? 3 plus the value of area A2 is 15 into y2 is 3.5, and the total area is 30 minus 15. Okay, this is how you can get y bar. What is the value of y bar?
2.5.
Okay, are you getting 2.5? Anybody else getting this answer?
Same, sir.
Same. Okay, 2.5 centimeters, right? So this is the value of y bar. Now, how to find moment of inertia about Ixx? Ixx is equal to, let me just choose a little different color. Okay, how to calculate Ixx now? Ixx. You can unmute yourself and answer. I'm asking you people how to proceed with Ixx, moment of inertia about x-axis. Hello. How to proceed? How to calculate Ixx? I'm asking you people. Just unmute yourself and answer.
Once show the figure.
Yeah. Okay. So this is the figure. So first, the regular method is, as usual, you find moment of inertia of this area about central axis, and then moment of inertia of this area about central axis. Okay, that is one method. But actually, we have already the moment of inertia of this area.
Yes, parallel axis theorem.
Yeah, about the base we have already. So why do you need to go again to regular method, right? So anyhow, we have this one using parallel axis theorem. You can get directly the moment of inertia about x-x axis. Okay, so Ixx is equal to here. Ixx is equal to let me say we know from parallel axis theorem IAB is equal to Ixx plus area, total area into the square of the distance between two parallel axes, which is nothing but y bar the whole square. Okay, so distance between two parallel axes is nothing but y bar only, no distance, right? So a into y bar, this is the actual formula, but therefore we need Ixx, we have AB, we have area, we have y bar, we have. So this Ixx needs to be calculated. Okay, and that value will be equal to Ix is equal to IAB minus area into y bar the whole square. So this is how you can make your problem, I mean, simpler. Okay, solution simpler. So IAB is equal to, we have 145 minus 145, right? So area is, total area is 15. Okay, and y bar is 2.5 square. See how simple the solution is. Otherwise, if you have chosen again in a regular method, then it would have been taken mostly 10 more minutes. Okay, so 145 minus 2.5 square, how much is the answer? Ixx. Hello, 15 into 2.5 square. 2.5 square is 6.25 into 15.
70.
70.
No, sir, no, sir.
1.25.
How much? Ixx, final value.
51.25.
51.25 centimeters square. I mean, square, is it square?
4 centimeter.
Centimeter to the power 4, yes. Okay, so that's how we will have to find the moment of inertia of this kind of figure. Okay, simple, in simple way. Okay, simplistic procedure you should adopt as simple. You need to make the problem as simple as possible while considering the number of areas and while considering the method about how which you will be finding the moment of inertia. So you can choose, actually speaking, the problem has ended here. I mean, here itself. Okay, this red color portion itself is the which completes the problem, which initially it was there. Whenever it was when this portion is not there, you need to only do this part. Okay, but we have added one more question, like finding the moment of inertia about x-axis, and in that case, you already have the moment of inertia about the base, and then you can find out the moment of inertia about central axis by parallel axis theorem. So this is how you should make the problem simpler and as simpler as possible. Okay, understood? Any doubt? Any doubt? Anybody?
No, sir.
Let's move on to the then let's move on to the next problem. Okay, so these are the kinds of problems you will be getting in the exam actually. This is the problem. Find the moment of inertia about the base for the shaded area shown in the figure. Also find the moment of inertia about the centroidal axis. Okay, even in this case, procedure will be same. Either you first calculate moment of inertia about centroidal. Actually, okay. See, if this is the question, now you can solve this problem in two ways. First, find out, anyhow you need to find out Ixx as well. You first find out centroid, and then find the moment of inertia about the centroidal axis. Okay, then find the moment of inertia about the base. That way also you can do it, or directly you can find the moment of inertia about the base and then find centroid and then find Ixx. So any one method you can adopt. Okay, am I clear? Right?
Yes, sir.
Okay, so now which method do you like to adopt now?
The base one.
Base one. Okay, let us adopt that and we can solve. Other way also you can do it. Okay, so let us first find out IAB, moment of inertia about the base. So IAB is equal to so now how many areas it has to be split into?
4, sir.
1, 2, 3. Okay. Actually speaking, the shaded area has not been mentioned. Actually speaking, this is the shaded area. Okay, let me just give different color. Some yellow. Okay. So this is actually the shaded area. It was not mentioned. Okay. So this is the shaded area. So definitely these are the negative areas. Okay, right. Now so definitely the number of areas will be 4. One positive triangle and one circle, negative rectangle, negative semicircle. Okay, we need to find moment of inertia of all these things, right? Okay, now so IAB is equal to IAB will be equal to IAB1 minus IAB2. Okay, so if we call this as a bigger rectangle, I mean triangle as A1, and let this be A2, and let this be A3. Okay, and this be A4. Okay, so then IA minus IAB2 minus IAB3 minus IAB4. Okay, directly you can use these formulas and you can find out the moment of inertia. Okay, now so we'll have to first mark the base. Okay, so this is the base. So this is the base. So let that be AB. Okay. So in the you need to write that statement as well. Let AB be the axis about which we need to find out the moment of inertia. So you just need to write that and then we should proceed. Next. So IAB1 will be equal to what I'll do. I'll write separately. IAB1 is equal to how much? IAB is equal to what is the formula of a moment of inertia of a triangle about the base? Actually speaking, the derivation what we did there, the triangle was like this, isn't it? It was a right angle triangle. Now, how do you find the moment of inertia of this kind of triangle? Can anybody have any idea?
Sir, we can divide it in two parts.
Actually, it's not necessary. Okay, so whether it can be, it's not necessary. Then it would have been 2 areas. Okay. So it's not necessary. There is no difference between this and this when it comes to the formula purpose. Okay, so one and the same. This height will be as usual, and because the base width will be there, no, so it will be double only. It's nothing but okay. As you rightly said, I can consider it as a 2 areas actually, but even then, so it will be divided into B by 2 and B by 2. No. So finally, if you calculate moment of inertia of this and the moment of inertia of this, it will be nothing but total moment of inertia only. So because what is the formula? BD cube by what is the formula? If h is the height,
BH cube by 36.
BH cube by 36 is for central axis because we are finding
H
about
cube by
base.
12.
BH cube by BH cube by 12. The formula will be, and you can see here this B is a linear term. Therefore, if you calculate moment of inertia of 1 and 2, it will be B by 2 plus B by 2. It will again become B only. So, no need to worry about whether it is a right angle triangle or apex triangle like this, isosceles triangle like this. Okay. So, formula will be same, no problem. Therefore, I can consider if this is B1 and total height. So, do you have total height here? We need to calculate it, right? What is the total height? Can anybody tell me? Calculate and tell me. 60 plus 30 plus 45. So 60 plus 30, 90. 90 plus 45, 135. 135 plus 20, 155. 155 plus 45, 200. 155 plus 45, 200. And how much is this?
15.
It is missing, right? So
15.
problem is wrong. 15. How do you get 15?
So that circle is given.
Since the diameter of the circle and the projections are same as this, so definitely this diameter also will be 30, and this is nothing but the radius r. So therefore this will be 15. So totally it will be 215. Okay, 215 is the total dimension. So therefore here the formula will be 150 into 215, the whole cube divided by 12. That is the moment of inertia about the base, minus area of this semicircle about the base. So what is moment of inertia? Moment of inertia of this A2 about the base. Moment of inertia of the semicircle about the base. What is the formula? What is moment of inertia of circle? Moment of inertia of circle is pi.
For semicircle, it is pi d power 4 by 128.
Yes, correct. So actually for circle it is pi d to the power 4 by 64. So if you are considering only half of the semicircle, which is nothing but, half of the circle, which is nothing but semicircle, it will be half of this, which is equal to pi d to the power 4 by 128. Pi into d is diameter is 30 to the power 4 divided by 128. Okay. Next, minus, and here since the base and diametrical axis were same, okay. So here there was no parallel axis theorem. Okay, but for these two we need to apply parallel axis theorem. Okay. Next, what is moment of inertia of this small rectangle? What are these dimensions? This dimension is 30, and this side it is 20. Therefore, 30 into 20 cube divided by 12. Okay, about because first we need to find out, this is G3. You should find out moment of inertia about this central axis. Okay, then plus area into square of the distance between two parallel axes. Okay, so plus what is the area? 30 into 20 into what is the perpendicular distance? Distance between two parallel axes.
80.
15 plus 45. That's nothing but 60. Is it 80?
70.
That's why I told every time you say something, think twice, thrice. Okay. So before substitution. So that's number 60 plus 15 plus 45 plus 10. Okay. 15 plus 45 plus 20 by 2, the whole square. Okay. So close the whole bracket, right? Next, the last one is moment of inertia of circle. Okay, moment of inertia of this circle about this base. So let us consider G force as the centroid of the fourth figure. So therefore, G4 will be equal to, the moment of inertia of circle is equal to, what is moment of inertia of circle? Diameter is 30. So pi d to the power 4, we know that pi d to the power 4 by, okay, I'll write, substitute the value as well. So pi d is 30, pi into 30 to the power 4 divided by 64. Okay, plus what is the distance from here to here? From here, okay, on this side I'll write. This distance, how much is this distance? 15 plus 45 plus 20 plus 45 plus 30 by 2.
140.
140, okay, 15, 60, 80 plus 60, 140, correct. So I'll write, for a description purpose, I'll write once again 15, okay. So area of the circle is pi into pi r square, pi into 15 square, okay, area into the distance, 15 plus 45 plus, you can see here, 15 plus 45 plus 20 plus 20 plus 45 plus 30 by 2. Okay, 20 plus 45 plus 30 divided by 2 whole square. Okay, square, and close the bracket. Okay, so that completes. Sorry, so actually this is total IAB1. Okay, here I'll just correct myself. Total IAB is equal to IAB1 and this minus IAB2, this part, and then okay, So this is IAB2 and this is IAB3 and IAB4. Okay. Now simplify and get me the answer. So meanwhile, I'll just some of you just calculate the answer and let me know. Meanwhile, I'll prepare the calculation for the center moment of inertia about centroidal axis. So if you want to calculate moment of inertia about centroidal axis, what we need to do first, we should find out, or we should locate the centroid. Okay, then we need to find the moment of inertia. Okay, about x-axis. So next is ixx. Let me take a different answer. Okay. Finding ixx. So to find ixx, we need y bar. Okay. So we need to find for ixx, we need to get y bar. Y bar value has to be obtained. So y bar is equal to a1 y1 plus a2 y2 plus, because there are 4 areas, a3 y3 plus a4 y4 divided by total area. Okay. Yeah, anybody got the answer? So I need to keep this screen open here like this. Okay. Anybody have the answer? Have you written down the answers? Just reply me. Are you calculating? Anybody? Who is calculating?
So I'm calculating.
Okay. This is actually okay. This is equal to 30 divided by 2 the whole square. So okay, I will keep substituting the these values. Okay, so y bar is equal to a1. A1 is the triangle, half into base into height, half into base is 150 and height is 215. Okay, so right, we will calculate one by one instead. So a1 is equal to half into 150 into height is 215. Right, a2 is negative because it's a negative semicircle. Pi into 15 square, pi r square by 2. Point r is 15 square divided by 2. You will get some answer. Next, a3 is equal to minus rectangle, the dimensions of which are 30 into 20. Then area of circle, which is equal to minus, it's also negative, pi into 15 square. Okay, get me these values as well. Okay, and next we'll have to calculate y bar values, y bar values. Okay, so y1 is equal to, okay, anybody got the answer for IAB? Hello? Hello, reply me, guys. Calculating. Okay. Please do it quickly. So 150 into 215 cube divided by 12, minus of pi into 30 to the power 4 by 128, minus 30 into 20 cube divided by 12, plus 30 into 20 into, this will become the 70 square. Okay. Minus pi into 30 to the power 4 by 64, plus pi into 15
So
square.
10.73 into 10 to the power 7.
10.73
into 10 to the power 7.
7. What is the unit?
Centimeter power 4.
centimeter to the power 4. Okay, this is the EIB value. So some of you can check and let me know the answer whether it is right or wrong. Is it correct? Okay, I'll assume that it's correct. Okay, let me see. Chandranshu, S is saying Y2, Y3, Akash. Okay, okay. So have you got the answer? Same answer?
Yeah, sir, same.
No, sir, calculating.
Okay.
1 minute, sir.
Y1 is nothing but distance of this centroid of a triangle, bigger triangle. Let the G1 be the centroid. Okay, actually speaking, that will be lying somewhere here, G1, because 1/3 from the base. So 1/3 of the height 215, and Y2 is nothing but distance of this semicircle centroid. So let G2 be the centroid of semicircle. So that distance will be equal to 4 into R by 3 pi. So which this R is equal to 15. Okay. 4 into 15 by 3 pi. And Y3 is equal to distance of G3 from this axis, which is equal to, we have already calculated that, 70, isn't it? 15 plus 45 plus 10, 70. Okay, that's equal to 70. Next, distance of G4 from here, which is equal to, we got it earlier. How much is the value? Which is equal to, you get here equal to 15 plus 45 plus 20, 80. 80 plus 125 plus 15, 140, isn't it? 15 plus 45, 60, 80, 125 plus 15, 140. Okay, so these are the values. Now you substitute these values in the y bar and get the value of y bar. Okay, yeah. So can anyone tell me what is area A1? Half into 150, 75 into 215. So here,
16,125.
okay, 16,125. So 16,125. Okay, centimeter square. Then A2 minus
353.25.
353 minus 353.15
25.
and 25. Okay, and this is 60, and this will be double this minus 600.
600.
Sorry, 7 not
6.95.
6.95 or 5, just 5 it will be. Okay, according to this I have written.
So that is 600 minus 600.
This is 600. Yeah, 600 centimeter square.
And that is A4, sir, last one.
Yeah, this is A4, correct. Okay, this is A4. Now substitute these values and get y bar. Have you got the value? Then let us do it. Y bar is equal to A1 16125 into what is 1/3 of 215?
71.66.
71.66 centimeter. Okay, and Y2 4 into 15 divided by 3 pi. It will be less than 15. You get how much it is? Even less than 7.5, less than 7. No, more than 7.5. Yeah, how much? 4 into 15. That's nothing but 60 divided by 3. 20 divided by pi. 8, 9 point or 8.7 point something we get. Four into R is 15 divided by 3 divided by pi. 6.36, is it so? I don't think this is correct.
Yes, sir, 6.36.
36, okay, 6.36. 6.37 I write centimeter, and okay, as usual 70 and other values. So 71.66 y bar plus A2 is minus 353.25. Okay, 353.25 into 6.37. Okay, plus I'll write the other one minus 600 into 70 plus minus 706.5 into 140. Okay, that whole divided by the total area 16125 minus 353.25 minus 600 minus 706.5. 706.5. Okay, so you'll get the y bar value. How much is y bar?
59.9.
59.69.
59.
Okay, 69.9 centimeter. 69.9 centimeter. Are you getting it? Anybody else?
Yes, sir.
Okay. So after you have this y bar and IAB, then we know directly, we know that IXX is equal to, we know from parallax theorem, we know from parallax theorem, okay, IXX is equal to IXX is equal to IAB minus area into y bar the whole square. Okay, so IAB we have, which is equal to 10.73 into 10 power 7, 10.73 into 10 power 7 minus area, total area. Do you have the value of this? 16125 minus 353.25 minus 600 minus this one. That value into y bar 69.9 square. What is the area of this? Somebody just calculate and tell me. 16125 minus 353.
Sir, 14,465.25.
Area.
Yes, sir.
Okay. Let me see. 41,000.
No, sir, 14.
Okay. 14,000. Okay. 14,000.
465.
465
Point
square
two.
centimeter. 0.25. Okay. 0.25 into 69.9 the whole square. Okay. So that will give you the answer. IXX.
0.66 into 10 raised to 7.
0.66 into
3.
10 raised to 7 or what? 3.66. Okay. So 3.66 into 10 power 7 centimeter to the power 4. Okay.
Yes, sir.
Yeah. Understood, right? So this is how you have to find out IXX from parallax theorem. So I think I have made clear all the things, right? Any doubt? Anybody?
No.
So I think you can solve any problem with any level of complexity when in case of moment of inertia. I think so, right? Are you confident now?
Yes, sir.
Okay, now what I'll do is I'll look into some more problems. Okay, I'll solve them and record the class, and I'll upload into CDMS website or YouTube directly. Okay, I'll be sharing those links in future. Please, I insist you to subscribe to my channel, so that because if there are any updates, you will be getting immediately. Yeah, okay, I need not inform you again and again in the group.
Sir,
No
we'll
need to like and
share
share.
also.
No, no need to like and share. Yeah, you can share with your friends. Okay, whoever interested. No need to like as well. You just go through. I mean, watch the videos, learn, and okay, you get ready for the exams. Okay, and don't think that exams may not be there. Don't think about all those things. You presume that there may be exams, written exams, and keep preparing for the final exams. Okay. And if you get any doubt in between, and you discuss yourselves whichever topic you wanted to be revised, you let me know. I'll be taking some classes.